Continuing with our exploration of probability, we're going to play a game here and we're going to kind of create a tree diagram, talk about some conditional probability, some multiplication of probability as well. So the rules of the game is there's 5 cards, 2 aces and 3 kings. If you're in person, you may be playing this in pairs. So a player chooses their first card, records the result, chooses their second card without putting the card back in the pile of 4 other ones, and records the result. So the way you win is you get a pair of aces or a pair of kings. So 1 and 2 you can work together to do, and we're going to use a tree diagram. We're going to calculate what the theoretical probability, what your probabilities should be if you play the game over and over and over again. So there are 5 cards, and there are 2 aces and 3 kings. So in our tree diagram right here, we start the game, our little ace game, and if we got options, either the first card drawn is an ace or the first card is a king. We know that there are 2 aces out of 5, the first 5 cards, and 3 kings out of the first 5 cards. So there's a 2/5 probability. 2 out of 5, you'll get an ace. 3/5, 3 out of 5, 3 out of 5 that you'll get a king. So once you draw that, let's say you draw an ace, then that means there's 4 cards total. So we have 4 cards total. And you already have 1 ace, so the probability of your second card being an ace is going to be the 1 remaining ace out of the 4 remaining cards versus a 3 out of 4 chance of drawing a king. Let's say we go down and you draw a king first. There are 4 cards remaining. And there are 2 aces out of the 4 and now 2 kings out of the 4 because you just drew your first king. So the probability to get an ace and then an ace, what we'll do is we'll take the probability of getting an ace the first time, that 2/5, and multiply it by the probability of getting an ace the second time, that 1/4. So we have 2 over 5 times 1 over 4, so we'll multiply across, so we'll have 2 over 20, which reduces to 1 out of 10. So we can say it's 1/10 or 0.1. If we were to get an ace first and then get a king second, then we would take our probabilities there. That 2/5 times the 3/4 multiply across is 6 out of 20, both divisible by 2. So let's reduce by dividing by 2, 3 out of 10, or 0.3. Same thing on the bottom half. The good thing is, though, we're going to take 3/5 and then we're going to multiply it by 2/4. If we go that direction and go king ace, or if we go king king, it'll be the same multiplication. So we can say that either of these are going to be 3/5 times, move that up a bit, 3/5 times 2/4, and we multiply across. That'll give us 6 out of 20, which will give us, again, 3 out of 10, or 0.3. So on those tree diagrams, I like to just wrap the tree diagrams up and put a little note here, and I like to say multiply down, in this case to the right, the tree. So we're multiplying as we go down the tree as we have more and more events occurring. Number 4 says find the theoretical probability of winning the game. How do we win the game? It's bolded right there. We win the game if you get a pair of aces or a pair of kings. So we got to figure out the probability of getting a pair of aces or a pair of kings. So the probability of getting ace ace plus the probability of getting king king. So the probability of getting an ace and then an ace is that 0.1. Probability of getting a king and a king is that 0.3. So we have 0.1 plus 0.3, and that'll give us 0.4 or 40% of the time you'll win the game. So a little note here, where we multiply down the tree, we add those final outcomes like we just did. And we're going to finish up with a little bit of conditional here. What is the probability that the first card was a king if we know the person won the game? So we want to know the probability of the first card, king, knowing that the person won. So we're going to take the probability of somebody winning, which we just found to be 0.4, and we're going to divide that by when somebody wins with the first card, king. So what's the probability of winning with the first card, king? It has to be right there. So that's going to be the 0.3. When we divide that, we can think of that as 3/4. And you guys know what 3 out of 4 is, 3/4 or 75%. So 75% of the time when somebody wins, we expect them to have won with king, king. And that should make sense that that's a higher probability than ace, ace, because we have 3 kings compared to just the 2 aces. All right, some general ideas on the next page. We have some big ideas, the general multiplication rule. And that's going to be basically what we were talking about with multiplying down the tree there. So we're going to have the probability of A and B is going to be equal to the probability of A occurring times the probability of B occurring given A has occurred. So that vertical line there for given, that's our conditional rule. If you hit shift and then the key above enter should give you that vertical line. If the events are independent, then it's a little simpler. So if A and B are independent, it's a little simpler because the probability of B given A is just equal to the probability of B, because A does not affect whether B occurs or not. So then the probability of A and B is going to just equal probability of A times the probability of B. And a final little note over here, the probability of at least one occurring is going to be the probability, there's going to be 1 minus the probability of none occurring. And we'll see examples of that in our future studies here. I do want to draw a quick little tree diagram off to the right and write some notes for tree diagrams. So we can say that first we have event A, either A happens or the complement of A happens. And that probability of A happening is going to be the probability of A. Probability A not happening is probability of complement of A happening, or we can do 1 minus probability of A. And then we can have a couple different things happening here, maybe B, C, and D, etc. And then the probability of A happening and then B happening, that'll be the probability of A and B, and we'll follow those rules to the left. A and then C, probability of A and then D, etc., etc. And so those are all going to be values, and a couple quick notes about that is we want to label the probabilities along the tree, all of the final outcomes should add to 1 or 100%. We want to multiply down the tree and add the outcomes. So for example, we should be able to add all of these up, whatever this is, whatever this is, plus all of these, and it should equal 1. And we can see that in our example on the previous page when we add up 0.1, 0.3 is 0.4, 0.3 more is 0.7, 0.3 more, that adds up to a total of 1. So that's all 100% of the possible outcomes are accounted for. Sometimes y'all forget something or mess up some math and you'll end up getting only 90% or 80%. You got to make sure we have everything accounted for. So you should be able to go do the check for understanding. Ask your teacher if you've got any questions. There's some more practice rule problems on the next page as well. We'll come back for lesson 3.4 in the next video.